Hello, Chemistry 20. Today I'm going to talk to you about another gas law called the law of combining volumes. And in order to get there, I'm going to introduce kinetic molecular theory, which is pretty much something that I think you've already seen in Science 10, but here we go. So, kinetic molecular theory, which I'll call KMT, describes matter as being made of molecules that are constantly moving. Another feature is the faster they're moving, the hotter that sample is. Okay, so according to kinetic molecular theory, the molecules of a solid and to a lesser extent liquid are close together. So solids have these tight bonds, and if you break them a little bit, the molecules can kind of fall over each other, and that's a liquid. But the molecules in a gas always spread out and fill their container. Okay, so if we change this container to even bigger, I've drawn 6 molecules, they would be even farther apart. However, you can actually condense this smaller and then they get closer together. This property of condensing, you can't really condense solids or liquids. They're a fixed volume. But gases, they have a volume of as big as the container they're in. All right? And that property explains both Boyle's law and Charles's law. Okay? So if you imagine that container again, if you squeezed it, if you compress a container, those little molecules are closer together and they'll bounce off the walls more. So that increases the pressure. Okay? Because it's producing more force against the walls. And that's what Boyle's law is all about. Similarly with Charles's law, if you increase the temperature, that gets the molecules bouncing around even faster. All right? And that's going to push out, like if the container can move, if the molecules push it more, the container will get larger and it increases the volume. You can imagine a balloon. All right? But the big thing for today is that kinetic molecular theory predicts the existence of this new law, the law of combining volumes. And it's actually pretty simple to apply, although this description is pretty wordy. So let me go over it. So here's the law of combining volumes. When measured at the same temperature and pressure, volumes of gaseous products and reactants are always in simple ratios. The ratio comes from the coefficients in their balanced reactions. Okay? I don't expect any of you guys to listen to that and then just the light bulb goes off and you get the law of combining volumes. But I'm going to show you in a couple of examples, and I think it's pretty simple to apply once you see it. So I've just set up a real simple formation of water vapor example. And then I'm saying if 2 liters of hydrogen gas reacts, so I'm going to write 2 liters under hydrogen. We can predict how much oxygen will be in the reaction and how much water vapor will be in the reaction. It's all related to this 2 liters in a simple ratio according to the coefficients in the balanced reaction. So I'll show you exactly what I mean. One thing to always remember is if you don't see a coefficient, it's a 1. All right, so there's 2 hydrogens for every oxygen, and when they react, they form 2 waters. Check this out. Here's how you apply the law of combining volumes. To find out how much oxygen is involved in the reaction, you take the amount of hydrogen, the 2 liters, and you multiply by the ratio of the coefficients. This is something you do a lot in chemistry 30 as well. The ratio of the coefficients is how many oxygens per hydrogen. Okay, so it's the 2 liters of the hydrogen multiplied by 1 oxygen for every 2 hydrogens. So it's 2 times 1/2. That means if 2 liters of hydrogen are involved, there's only 1 liter of oxygen. Okay, getting this ratio is the crucial step. And I'll give you kind of a tip in the next example to help you remember. Getting this water, the amount of water involved, is going to be real straightforward. It's the 2 liters, and check it out. They each have a 2, so it would be 2 over 2. That's just 1. there'd be 2 liters of water involved. Okay, so just so I don't leave this sentence hanging, I'm going to say if 2 liters of hydrogen reacts, 1 liter of oxygen reacts, and 2 liters of water vapor are formed. Okay, so I've got 2 more examples that I hope drive this home. These are the types of questions that I've just got in today's assignment. Okay, so I'm just saying write the volume of each reactant and product in the following reactions. Okay, they're already balanced for us, and I've given the volume of one of the reactants. So this first one, it looks like it's combustion of methane, and we know that 2 liters of methane are involved. Okay, so to find the oxygen, we start with that 2 liters, and we multiply by the ratio. We're looking for oxygen, so we start with the oxygen number, the oxygen coefficient. In this case, it's a 2. Remember, if there's no coefficient, it's a 1. So it's 2 over 1. Okay, so 2 times 2 over 1. That means there's going to be 4 liters of oxygen in this reaction. Okay, for carbon dioxide here, start with the 2 liters. We want to find carbon dioxide, that's a 1. CH4 is a 1. 2 liters of carbon dioxide. The water here, 2 waters for every methane. We get 2 liters. Okay, and if you're looking for a pattern, the coefficients 1, 2, 1, 2, the volume's 2, 4, 2. This should be a 4. Sorry, guys. I'll have my editing team edit that out. There's no editing team. All right, let's take a look at this last one. Something interesting is going to happen in this one. So I got, well, this is an interesting reaction. Hydrogen sulfide and some sulfur dioxide. Okay, we're starting with 50 mils of this stuff. Well, let's dive in. Got this SO2. I'm starting with 50 mils. The ratio here, we're looking for SO2. That's the 8. So the top number in your ratio is always what you're looking for. It's like what molecule you're writing below. All right. So it's going to be 8 over 16. That's a half. I'm going to end up with 25 milliliters. Okay, let's talk about this sulfur here. It's a solid. The law of combining volumes means volume of gaseous products and reactants are always in simple ratios. Okay, solids and liquids don't fill the container. So we can't actually predict how much there will be in terms of volume. So just don't do anything. Okay, and I'll write underneath, ignore solids, but also liquids. That's it. That actually makes your life easy. And just be aware of these state symbols. They're very important because they'll tell you whether or not you actually have to do anything. This water here, we're starting with the 50. The ratio is going to be 16 over 16. So we're going to get 50 mils. All right, that's the law of combining volumes. I hope this helps. Good luck.